I will discuss about global system for mobile communication, that is GSM. So GSM is a second generation computer. Now it will be available in India. So in second generation computer we have data and voice transmission is available. So this is GSM. So in this GSM we have 9.6 kbps speed is available. That is a second generation computer. So in this 9.6 kbps speed is available. So that is the main task using in a GSM architecture. So in this GSM architecture, so only disadvantages is that only 160 characters are available for using in sending and receiving data. 160 characters sending and receiving data. So next, so this is one of the digital cellular technology. So digital cellular technology, so that is, so what is the frequency band is available in 900 to 1800, so frequency band. Frequency bands is available in this GSM architecture. So this is the main introduction part of GSM architecture. Next we are using GSM services. So GSM services, the first services is bearer services. Second one is on tele services. Third, we are using in on supplementary services. Supplementary services. So the first we are using in on bearer services. Bearer services is on data and voice services. It is another name is on data services. So in these data services, so we are sending and receiving the data. So the only bearer services is on data services, sending and receiving the data. So it is only for using in email services, then SMS services, etc. So in bearer services we are using in two different types. The first we have transparent bearer services. Transparent bearer services. Second, we are using in non-transparent bearer services. Non-transparent bearer services. The first we are using in transparent bearer services. In transparent bearer services is only for using in physical layer of OSI model. So it is what are all the functionality available in OSI physical model. OSI physical model. So in this physical model we are using in forwarding a data, so no transmission errors are available. Next one we are using in non-transparent bearer services. So in this non-transparent bearer services, flow control and flow error is available. Flow control and flow. Okay, so these are the bearer services. Okay, so in the bearer services, data services, these data services is on sending and receiving the data. Okay, so next we have, so second services is on tele services. Tele services. Okay, so in the second services is on tele services. So in these tele services we are using in all the telephonic functions are available. So all telephonic functions are available. In these tele services we have, so different varieties are available. The first we are using in telephony. Second we have SMS. Then fax. So telephony, SMS and fax. So in this telephony only for using in sending in digital voices. Okay, so in this digital voices services are available in telephony. Then we are using in SMS. Okay, this is short message services. Short message service. So in these short message services, so in this teleservices SMS is only so up to 160 characters are available for sending and receiving data. So 160 characters are available for sending and receiving data. Next, fax. So fax is a normal thing. So it is only for using in sending in digital to analog data. Digital to analog data. So this is on teleservices are available. The first we are using on telephony. So it is only for using on telephonic services, SMS and fax. Next, third we are using on supplementary services. Supplementary service. Supplementary services. So in these supplementary services, so what are all the main functionalities are available in supplementary services is on call forwarding, call redirecting, and call group. Okay, so these are the supplementary services are available. So the first, call forwarding, call redirection, and call group call. Okay, so these are the services are available in supplementary. So this is a system architecture of GSM. So in this system architecture we have three different partitions are there. The first part we have RSS, radio subsystem. Second we have NSS is a network switching subsystem, and last one we have OSS, operation subsystem. So the first we have RSS, we have these are the components are there. The first component is an MS, okay, that is mobile station, then BTS base transceiver station. So then we are using in on BSC base station controller, then BSS base station subsystem. So these are the components are available in on the first part RSS, and the second part we have NSS. So in this NSS, MSC, that is the first component, and the second component is on VLR, HLR. Last we have GMSC. The first component is on MSC. MSC is on mobile switching center. Second VLR. So VLR is on visitor location register. HLR is on home location register. Finally we have GMSC. So gateway mobile switching center. So these are the components are available in NSS. And last we have OSS. In this OSS we have three different components are there: EIR, equipment identity register, AUC, authentication center, and OMSC. So OMSC is an operation maintenance center. So these three different parts are available in the system architecture of GSM. The first, so in the first RSS, MS is a first component. So in this MS, that is a mobile station. In this mobile station we have, so mobile devices are there. So then we have BTS base station, base transceiver station, and BSC base station controller. So mobile phone. So in mobile phone we have, so two different components are there. The first component we have, so IMEI number, then SIM card is another one component. Next we have using in on, so mobile device. So these three different components are there. So in mobile phone, SIM card is a first component. So SIM card is a very important component in on mobile devices. So in these mobile devices, so SIM card. So using a SIM card, we will store all the information about the data. Next BTS. So in this BTS is a second main component. So in this component we are using in on all the radio entities are available in this BTS. So in this BTS, every signal will be going to transmit in on these digital waves. Then it will be going to encode the data, then it will be going to using in on carrier way, then it will be going to feeding in on RF. Okay, so these important component in on this BTS. Then BSC, so base station controller. So in this base station controller, so all the radio entities are available, followed by, so in these functions of the BSC is on, it will be going to assigning all the frequency bands to MSC. So that is the second part in on BSC. Next BSS. So in this BSS is on encoding and decoding in on voices. Okay, so next NSS. So NSS we have MSC, VLR, HLR, and GMSC. So first MSC. So MSC is on mobile switching center. It is a part of on GSM. So in this MSC, so all the billing so will be so all the subscriber billing will be going to providing in on so every mobile networking. So next VLR. So VLR is an visitor location register. In this visitor register is act as an so one of the database. So in this database, all the, for example, so every data, I mean, and the user will be going to assigning, I mean, and the roaming in another one location. So this will be going to, so all the information will be visitor information will be going to storing in VLR. So in this VLR act as a temporary database, HLR will be act as an so permanent databases. So in these permanent databases, subscriber information is available in this HLR. So HLR having in on all the subscriber information like phone number, everything will be going to sending storing in this HLR. Next we are using in GMSC. So this is Gateway Mobile Switching Center. So in this Gateway Mobile Switching Center, suppose any visitor will be going to, so I mean, and the so mobile any visitor will be going to so visit in the particular places. This will be going to so sending all the information to the next network. Next OSS, Operation Switching Center. So in this EIR, AUC and OMS is there. So in this EIR, Equipment Identity Register, so this will be going to act as an so this one of the databases. So database having in on so all the information about the visitors informations. Next AUC, so this will be going to using in on all the, I mean, and so these encoding and decoding techniques are available in this AMC. So this is Operation Maintenance Center. So this will be going to maintaining all the information about the network. So this will be on system architecture of GSM. So medium access control protocol. So that is a MAC protocol. So in this MAC protocol, so maximum utilization of the channel is more. So what is the main objective of this MAC protocol? So for example, sending the data, so different node will be available. So for using in wireless communication, for sending the data at a time, in that situation arbitration problem is there. So that situation only, so in this MAC protocol, two different problem arises. The first problem will be an hidden terminal problem, and the second we have exposed terminal problem. First, so we will discuss about hidden terminal problem. So in this hidden terminal problem, A, B and C, so three different nodes are there. The first, A will be sending the data to B, at the same time C will be sending the data to B. So in that situation, A will be on different radio range and C will be on different radio range. So in that situation only, so this A and C will be on hidden. For example, A will be on different radio range and C will be different range. So in this situation only, so these A and C will be on hidden. So that arises will be hidden terminal problem. So next, so exposed terminal problem. So in this exposed terminal problem, so first in this A, B, C and D will be there. So 4 different nodes are there. Same problem is available, but A will be sending the data to B. So at the same time B will be busy and C will be sending the data to B. So in this already A will be sending the data to B. So in that situation, so C will be so waiting some time. Okay, so C will be waiting some time. So C will be going to searching in on another one node for sending the data. So in that situation only, so exposed, for example, C will be exposed to A. So what kind of problem will be arises is an exposed terminal problem. So how it will be going to so overcome this problem, so hidden and exposed terminal problem. So in this overcome this problem, so this MACA technique is there. So medium, so that is MACA is an medium access control, for example, medium access control avoidance technique is there. So in this A, B, C different technique, different nodes are there. So in that situation, first A will be sending in on RTS message. So RTS message. So in this RTS message is a request to send message. So in that, so request to send message, B will be so first, so reply to B, so CTS message. That is on CTS will be on clear to send message. After that only A will be sending the data to B. So in that time C will be waiting. So that is on hidden terminal. So problem, I mean hidden terminal problem So that will be A will be sending the data to RTS and B will be clear to send message and C will be waiting. So in that situation, so hidden terminal problem arises, but hidden terminal problem will be overcome in on MACA techniques. Next, exposed terminal problem. So exposed terminal problem arises we are using in on. So A will be sending the data to RTS. In same time, C will be sending the data to RTS message. So the first A will be sending the data to, so request to send message to B, and C will be sending the data to RTS. I mean request to sending the message to B. So in that time, B will be sending to clear to send message to C. So in that situation, so these B and C will be on waiting. So same time, B will be sending the data to C. So in that situation, exposed terminal problem will be solved. So next we will discuss about taxonomy of MAC protocol. So that is medium access control protocol. So in this taxonomy, so we have three different partitions are there. The first we have fixed assignment scheme, second we have random assignment scheme, and third we have reservation based scheme. So in this first fixed assignment scheme, so in this first fixed assignment scheme we are using non FDMA, that is frequency division multiple access. Then we are using in non TDMA. TDMA is on time division multiple access. Third we are using in non code division multiple access. So frequency division multiple access, time division multiple access, and code division multiple access. First we have frequency division multiple access. So in this frequency division multiple access, available frequency will be going to assigning in different frequency bands, CH1, then CH2, CH3 and CH4. So in frequency division multiple access, this will be on frequency. So this will be going to divided into one. So different frequency bands. The first band will be going to assigning in on channel 1, second band will be going to assigning in on channel 2, and third will be channel 3, and so fourth will be on channel 4. So this is on FDMA technique. So in this FDMA, so fixed frequency will be going to assigning. That is one of the disadvantages is on. So this frequency division multiple access. Next we are using on time division multiple access. So in this time division multiple access, different time slot will be going to assigning. This first one channel 1, channel 2, channel 3, channel 4 and channel 5. So the first frequency bands will be going to assigning in on channel 1, second will be channel 2, third will be channel 3, fourth will be channel 4, then fifth will be channel 5. After completing this will be going to using non-round robin techniques. Okay, so the next will be going to using non channel 1. So this will be on time division multiple access, that is TDMA. So time division multiple access is on time division, so a different frequency will be going to assigning the particular time slot. So this is called the time division multiple access. Next, code division multiple access, that is a very important part in on this fixed assignment scheme. So in this code division multiple access, code, so that is code will be going to assigning in different channels. So code will be going to assigning in different channel. Okay, the first, so X and Y will be there. So X there, Y will be there, and Z will be there. So in this, X will be on sending the data and Y will be on sender. So that will be going to sending the data, and Z will be on receiver. So this will be receiver. X will be sender and Y will be another one sender. So in this code division multiple access, so in this X will be going to, so using in on X data, that is called 1. So then, so X key will be 0 1 0 0 1 1. So that is will be on key. So in this Y will, sender Y will be Y data and Y key. So y data will be 0 and y key will be 0 0 1 0 0 1 1. So in this score division multiplexers, so this will be going to using in an x data plus x key equal to z. So in this x data will be 1 and x key will be plus x key will be 0 1 0 0 1 1, that is equal to z. So for example, so it will be going to applying on autocorrelation techniques. So in applying on autocorrelation techniques, 0 will be called as minus 1, 1 will be called as plus 1. So this will be autocorrelation techniques. So in this, for applying in an autocorrelation techniques, this x data will be using in on 1 plus 1 and y data will be, sorry, x key will be minus 1 plus 1 minus 1 minus 1 plus 1 and plus 1. So this will be called as x. Next we are using in on x key. So in this x key, so this will be minus 1 plus 1 minus 1 minus 1 plus 1 and plus 1. So next we are applying in on y data. Y data equal to 0 and y key will be 1 1 0 1 0 1. So for applying in an autocorrelation techniques, y data will be called as minus 1 and y key will be called as plus 1 plus 1 minus 1 plus 1 minus 1 plus 1. So next, so we are using in on for sending the data xs plus ys equal to z. So in that situation, xs equal to x data into x key plus y data into y key equal to z. So in this x data will be what? So for applying an autocorrelation techniques, minus 1 plus 1 minus 1 minus 1 plus 1 and plus 1, that is called the x data. So for example, we have substitute this value. We have substitute this value plus 1 into minus 1 plus 1 minus 1 minus 1 plus 1 plus 1 plus y data. This is called the x data and y data will be on minus 1 into plus 1 plus 1 minus 1 plus 1 minus 1 plus 1. So for adding these two values, that is equal to 0 1 minus 1 1 comma minus 1 1 minus 1 plus 1 plus 1 minus 1 minus 1 plus comma, for adding this value minus 1 plus 1 minus 1 plus 1 and minus 1. So this is called x data. So next we will, so adding those two value, minus 1 0 minus 2 minus 1 0 minus 2, 2, 2, 0 and 0. So this is called X data. So after completing this X data, so it will be going to sending in on Y. It will be going to sending in on Y. So that is XS plus YS equal to Z. So it will be going to sending in on Z. So after completing this, Z will be 0, minus 2, 2, 2, 0 and 2. So this will be on Z. So after going to complete this Z value, then so we will verify all those values. For example, so X data into Z. So that is equal to X data will be 1, then followed by 0, minus 2, 2, 2, 0 and 2. So this will be on the first data, and the second for verifying this value, that is equal to Y data into Z. So that is equal to Y data will be minus 1 followed by 0, minus 2, 2, 2, 0, 2. So this will be going to, so sending the data after receiving the data, so this will be on result. Okay, so this is called code division multiple access. So after completing this code division multiple access, next so we are using in on random assignment scheme. So in this wireless MAC protocol, second random assignment scheme. So in this random assignment scheme, the first CSMA, so CSMA is on, so CSMA, CD, third CSMA, CA. Carrier sends multiple access. So this is will be on carrier sends multiple access collision detection techniques. Third will be on carrier sends multiple access code avoidance techniques. So carrier sends multiple access code avoidance technique. So in this random assignment scheme, these three parts are there, and finally we are using in on so reservation based scheme. Reservation based scheme. So in this reservation based scheme, so first all the channel will be going to reserved. After completing this, suppose so any data will be, for example, any communication will be arises, after that only it will be going to sending the data. For example, any channel will be going to busy in that time only, so for sending the data. So in this reservation based scheme, we are using in on MACA techniques. So multiple access collision avoidance techniques. So this will be on hidden terminal problem solving techniques. So in hidden terminal problem already completed. So in this hidden terminal problem solving techniques, multiple avoidance collision avoidance techniques. So in this hidden terminal problem, suppose so three different channels are there, A, B and C. So in this A will be on different radio range and C will be on another different radio range. So in that situation A and C will be on hidden. The same time A will be sending the data and B will be on sending the data. In that situation collision will be arises. Okay, that is called a hidden terminal problem. So for example, in reservation based scheme, all the channel will be going to reserved. After that only, so it will be sending the data. For example, A will be sending in on RTS message, C will be sending in on. So again RTS message will be on request to send data. So after completing this, so B will be sending in on CTS message. Okay, clear to send message. So for example, B, whenever B will be so sending the data to A, in that time A will be receiving that, then only it will be going to sending to B. So in that situation, so collision will be going to avoid. So this will be on the first hidden terminal problem arises techniques. And next we are using in on So next technique will be hidden terminal problem and exposed terminal problem arises. For example, A, B, C and D will be there. So in that situation, A will be sending the data to RTS message. In the same time, B will be sending in an RTS message. Whenever, so any channel will be going to sending to B. So in that situation, so in which channel, so we will receiving in on CTS message, then only it will be going to sending the data to, so this C. So this is called MACA, that is exposed terminal problem solving techniques. So up to this taxonomy of MAC protocol, so then MAC protocol issues. So after completing this, hidden and exposed terminal problem solving completed. So thank you.